I'm going to do some live coding to show how MachineBox works. And MachineBox is super easy to use. It's kind of like machine learning in a box. It allows you to do a whole bunch of different things. You can do face recognition, face box, tag box to categorize text and do sentiment analysis. New box, fake box, which I've got to try, and we're going to have to do a session on how fake box works to check fake news, and a whole bunch of other stuff. And it just kind of runs in a Docker container, and it's really easy. Really nice API. And what we're going to do is we're going to build an OpenFaaS function. And OpenFaaS is your kind of functions as a service, or your own serverless platform on your own infrastructure, your own cluster. You can run it on Kubernetes, Docker, Swarm, Nomad, a whole bunch of different places. What I like about this serverless approach is that I can write really small functions like we're going to do in this session in Golang, and I don't need to worry about packaging or anything like that. The FaaS CLI is going to do all of that for me, so I just need to write my code, write my tests, and I've got a very simple API endpoint that I can integrate into my existing stack. And because it all runs on Docker, I can literally deploy it pretty much everywhere, so it's very, very flexible. So what we're going to do is we're going to take an image, we're going to try and detect some faces in that image from MachineBox, and then we're going to draw some borders around the image. So let's get going. Okay, so what I need to do first is I need to create myself a new function using OpenFaaS. So I'm going to use the FaaS CLI, and I recommend checking out the documentation. I don't want to kind of go into it too much in depth in here, but maybe we'll do a session on how to set up and use OpenFaaS. But I create a new function with FaaS new. I'm going to specify the language is Golang, and I'm going to give it a name. I'm going to call it MachineBox. MachineBox. Okay, so that's created. What that's done is it's created me a YAML file which has got the details such as the image and stuff like that, and it's also created me a handler. So there's the YAML file, and here's our handler. So for Golang, the handler is kind of similar to the HTTP handler that you might be used to, but it's much, much simpler. So what you have is an input, which is a slice of byte, and an output, which is a string. And internally, OpenFaaS kind of manages calling of this. So literally all you need to do is put the implementation into this handler. To make things easy for us, what I'm going to do is I'm going to add a Golang test file. I'm going to call it handler_test.go. And I'm gonna use this primarily in this example for just sort of doing some kind of functional testing. I don't want to have to keep building my code every time I kind of make a mistake. So I'm going to use the handler, the test to do that. Tomorrow, what I'm planning on doing is actually another session which is going to take this code, and we're going to look at it and we're going to see how we can actually write some good unit tests, and actually how you can take a test-driven approach to OpenFaaS as well. So first things first, let's just write our very, very sort of basic test. So in Golang, that's func. I always start with the word test. I'm just going to call it functional test. Then I have to give it the right signature, which is T. It's a reference to testing.t. And initially, let's just make that test fail. So t.fail. And then that's done my import. So now what I can do is, if I change to the right folder and we can see I've got two files there. So if I run go test dash v, because I want verbose, and all test files. We can see that that test fails as it should. All right. So the next thing we want to do is actually start writing out our code. And what we're going to need to do in this handler, we want to pass in an image. So let's go and find an image on the internet. Every time I do this, I just can't think of an image that I should be using. So let me troll Armon, because I work for HashiCorp. So let me troll my boss and our CTO. And there's a great picture of Mitchell and Armon, and we're going to use this. We're going to see if we can detect some faces in this image. All right. So I just saved that to my downloads function. I'm just going to call this hashi.jpg, and let me copy that into the MachineBox folder that I created before. All right. So I've got that now. Now, when I recorded this somewhat badly last time, and I couldn't figure out quite what I was doing with the software, a few people were asking what setup am I using. So the setup I'm using is I'm using Alacrity, which is a GPU-enabled terminal window, and from testing it over the last few days, it is amazingly fast, like so much better than iTerm. And I do all my coding in NeoVim, NeoVim, which is like super cool. Whilst sort of Vim 8 added a lot of async, NeoVim was built from scratch to have async. I just like it. You choose what you like and just roll with it. But I'm using Fatty's VimGo, which gives me a sort of a Go ID, and I can do all sorts of things like get code completion with deoplete and all sorts of stuff like that. I've also got integration with GoDoc. I can use the GoDoc command, and that'll pop up in a window there. I find this a really, really, really productive environment, but you don't need to use this. You can use Visual Studio Code or anything like that. All right, so anyways, back to the point. So we've got our image. We've got hashi.jpg. So the first thing we need to do is we need to pass that as a slice of bytes. So we can do that by reading the file. So the first thing we need to do is we need to read our file. So we're going to do f error equals, os.open maybe. And rather than doing from snippets, I'm doing this like as I would code it. So you're going to see all of the mistakes, of which there will be plenty. Hashi.jpg. Okay. And then what we need to do is check if error then t.fail. So again, this is more of a functional test. It's an integration test with MachineBox. I'm using checking my errors, which is good practice in Go. It doesn't take much time, so it's not the end of the world. The next thing I want to do is I want to read that file. So I'm going to get data.error again, and I'm going to use ioutil.read all, and that takes a read closer, I think, which file is. Again, I'm going to check that error. If error is not nil, t.fail. Okay. So let's then pass that over to our handle function. So I'm going to call handle, and I'm going to pass it data, which is my slice of bytes, and then we can test this. And when we test this, what we should see is we should see that file just getting spooled out to the command line window, and it'll just be a big mess. Well, it would do if I was actually returning the content, wouldn't it? So we'll do out, and then we'll just do format.println out. Cool, you can see the junk there, so the file's getting read. All right, so the next thing we need to do is we need to do something useful with that file. So we're going to take that file and we're going to make an API call to the MachineBox box. So if you check out MachineBox, bear with me, I just find the right page, then literally all you do is run a Docker container. You do need an API key, but you can register for a free account on MachineBox. So you run your Docker container. Literally, you only need to specify the API key as an environment variable and specify a port. I've actually got this running already just to save a little bit of time. And we can see that that's running there, FaceBox, and it's on IP 192.131.80.80. One of the other cool things about FaceBox is you kind of, when you run this container, you get this really nice kind of documentation site, and it's got the ability to do sort of live demos and kind of just get up and running really, really quickly. Got all the API documentation here. Super easy to use. Definitely recommended if you want to get into machine learning and just kind of want to do some fun stuff. So we've got that running there, but what we're going to do is we're going to use the Go SDK. So I need to see if I can find the docs for Go SDK. There we go. Box specific APIs. SDKs. There is an awesome Go SDK. I don't want that. I want the documentation for the Go SDK. Cool. So we're going to use the FaceBox SDK. So what we need to do with FaceBox to actually make it work is we need to create a new instance of the client, which we do with the new function. We specify the address for our MachineBox Docker container, and then we're just going to use check. And check has an input parameter of an IO reader, which we've already got, and it'll return us an array of, a slice of faces and potentially an error. And the slice of face is just a simple rectangle, and we get some IDs and some match and some confidence and some really nice stuff. So I need the import path for that. And let's go and throw that into our code. Right. So I'm going to import FaceBox. I don't want that anymore. I'm going to create a client. So it's going to be FaceBox.new. The address of my client is going to be my Docker container, which was, bear with me, I had it here just before. There we go. So that's there. And then what I'm going to do is I'm going to do c.check, and the request that I've got is a slice of bytes. Now I can't use this directly in the check function because I need an IO reader. But what I can do is I can just do bytes.new reader, wrap my request in that, and there we go. Oh, okay, so just quickly, I'll just clean this up before I deal with that error message. So I'm going to do faces, error, and my IDE is telling me that it can't import the FaceBox SDK. So what I need to do is I use dep I'm just going to do def init, and that's going to pull down my dependencies that I need from and put them into a vendor folder. Right, so I save that again, and now I'm getting some different errors because I'm not using faces or error. So let's just check for an error. So if error is not equal to nil, then I'm just going to return sprintf, and I'm just going to say error getting faces, and then let's include the error message in that as well. However, if I do get my faces, then I want to sort of just, I'm going to process those, but for now, let's just check to see this part's working. Let's just output those. So I'm going to do return, and again, format.sprintf, and I'm just going to do faces, and I'm using %#v, and what %#v will do is it'll it'll serialize the object, but it'll give me a little bit more information than if I just serialized it without the hash. Okay, so again, I'm going to run my unit test, which I'm using. And look, we've got two faces in there. I'm reading the API wrong. It's because it hasn't recognized them as anybody that's in the model. That's another cool thing about FaceBox, which I'll have a play with some time because I want to get that running for Selfie Drone, but you can actually train it to recognize faces as well. All right, so this is all working great. So the next thing we want to do is we want to mark up that image, and we want to draw a nice border around the faces. So what I need to do is I need to draw that image. Now, Golang doesn't have any easy way of, it doesn't have like a graphics canvas as part of the base packages. It's got some great image libraries, but nothing like that. So I'm going to use another library. So let me just grab that link. So I'm going to use Draw2D, which is a pretty sweet library, and this is going to allow us to add those rectangles, because we've got the capability of doing begin path, and we can move the line and all sorts of stuff like that, which is a little bit more difficult when we want to do that with the raw Golang libraries. So the first thing I need to do is I do need to create to import an image. So my source image, I'm going to call it source. That'll probably have an error. Now, image dot, I can't quite remember the syntax. So let's have a look at that. I'm sure it's got an encode, or does it have a... I'm sure you have an encode. Decode. Oh, there it is. I've just gone past it. There we go. So we can use the image decode, and that takes a reader, and it'll give us back an image, a string of the type of image if it matches the format, and potentially an error message. So I'm going to do image.decode. I'm going to, again, I'm going to use bytes.newReader. I could have only initialized this once, I know, but I'm being lazy. I'm not bothered about the image type. I'm bothered about the error. So if, again, for anybody who's not used to Go programming, they kind of look at this error equals not equal new everywhere, and they find it a little bit verbose. It's actually a good thing. Being very explicit about handling your errors sort of forces you into writing good code. So I'm actually a little bit of a fan of it. So error decoding image. So we're not using source, that's fine. So the next thing we need to do then is we need to use our draw 2D. So what we do is we create a graphic context from our image. And if anybody's ever used this reminds me of the C# APIs for drawing stuff, when I used to use that way back when. Right. So we just need to get that import statement as well. And again, I just need to download those packages. So I'm going to use dep ensure. And that'll just take a little while. Okay, we got it. Okay, so new graphic context, source. Now, I ran into this problem when I did this the first time. It says it can't use source because variable of type image.image is not compatible with draw image because it's missing the set method. You can actually convert this in Golang in 3 lines of code, of which, of course, I've got the memory of a sieve. I can't remember what it is. So I'm going to should be able to find it by Googling last time, however. So what we're going to draw is image. We want the bounds. We're going to put this source, bounds.minimum, and draw.source. And then what we can do is we can use this one in there. Okay, and that's working now. It's just telling me that I've declared it and I'm not using it. So what I want to do is I just want to set up some of the attributes. So I'm going to set the fill color. Let's see which, choose a different color. Let's use, do we have yellow or something? Oh, don't make me do something. Like, no, I'm just going to use black. I can't be bothered. Rather than trying to figure out the codes for creating it from an RGB. Then I'm going to set the line width. I'm going to set that to 2. And then it's time to loop over our image. So it is 4. I don't really want the index property. So face in range faces. And then every time I sort of loop over a face, what I'm going to do is I'm going to draw a box. So I'm going to do gc dot move to. So I need to move to the top left corner of our image. So I can get that from f dot rect dot left and f dot rect dot top. And this is telling me that so draw 2D wants a float, and I've got an integer. So let's just convert those. And then what I want to do is draw a line. So I'm going to draw a line to, and I want to draw, I'm starting at my point here. I want to draw my line to this point here. So the line 2 is going to be float64 f dot rect dot left, and I'm going to add f dot rect dot width. So I'm moving this point and I'm staying on the same y-axis. So that is just going to be float f dot rect dot top. Say that right. So we need to do that a couple more times. So we now need to draw down, then we need to draw back, and then we need to draw back up. So I'm going to keep the x the same on this, but when I go to the top, I'm going to go the top dot rect dot height. So I'm going to draw down. And then what I need to do is I need to draw back. So I'm going to go back on the x-axis. And then again back to our original 0 point. So that will complete our line. Then we can do gc dot, I can't remember what it is. Is it fill path? Close and fill stroke. Cool. So that's going to loop through. That should be putting all of our images on there. What we want to do is we want to write that out back to the the OpenFaaS function. But just to check it out, what I can do is let me just save the file to a PNG just to check it's all working. I'm just going to save it at temp dot stuff. Why not? And that requires an image, which is going to be my image. Cool. So fingers crossed, and I'll be surprised. It doesn't normally do it like that. So let's open the image. So we're going to do temp stuff.png, and that is not the right image. I don't think that's working. So let's have a look at what's going on here. Okay, error decoding image unknown format. Right. I do this every time I use image. So I need to import image format for JPEG and PNG. And then let's run that. Okay. And there we go. You can see we've now anonymized Mitchell and Armon. But let's change that so we get a nice border rather than hiding them, because they are both lovely people and they don't deserve to be anonymized. So what we're going to do is we're going to do gc.set. Oh, I've set the fill color. Okay, so set the fill color, color.transparent, and I want to set the line color, or the stroke color. There we go. Let's run that again. Oops. And it's pretty quick. MachineBox is, I mean, including this whole test, is running in 1.6 seconds, so it's pretty neat. And there we go. So we're detecting some images, some faces in that image, and we've drawn a box around the image, and that was pretty easy. I mean, I have done this once before, fair enough, but I'm making pretty much the same mistakes at the same time. But the first time I did it, I literally didn't research this at all, and I still got through this in an hour. So what we're going to do now is rather than saving that file into my temp folder, which is no use to anybody, what I want to do is return that as a byte array. So I can use, with there being a decode, there will probably be an encode. So let's save it out as a PNG. So PNG dot PNG dot encode. This takes a writer, so I'm just going to give it a buffer. Bytes dot buffer. We need a reference. Grab a reference to that. And then all we need to do is output that in the return. So we're going to have to convert it into a string because that's what OpenFaaS wants. And I'm going to do buff.bytes. So I'm going to get the bytes out of the buffer. I'm going to save that. We're going to run that again. So that's looking good. I've actually got an image out of the function. So what I can do now is I can go ahead and I can build my OpenFaaS function, and then we can push it to Nomad and see how it works. All right, so same as we create a new function, we're just going to use the FaaS CLI. So we're going to do FaaS build. We need to tell it which thing we want to build. So we're going to do MachineBox.yaml. I need to make a couple of quick changes to my MachineBox.yaml, because what I want to do is when it creates an image, I want to be able to push it to Docker Hub. So I'm just going to put the path of my Docker Hub in there. And while I'm in there, oh, that'll do. Okay, so FaaS build MachineBox.yaml. So that is dealing with all of the Docker build stuff for me, which is super nice, super handy. It's a really nice workflow for building quick and useful kind of components for your system like this. So that's all built. In the same way, I can just push that to the Docker registry. So and that's getting pushed there now. It's quite a small Alpine-based image, so including the Go application and some of the other bits and pieces for OpenFaaS, it works out at like 10 megs, so it's pretty awesome. And then what I want to do is I want to deploy that to my OpenFaaS. So I've got Nomad running, as I was sort of saying earlier. I'm using the Nomad flavor of OpenFaaS, and if we go to OpenFaaS, we can see I've got a couple of functions here. I've got a face detect one, which is using OpenCV, and I've got a tweet function, but we're going to push our new function there as well. So we're going to use FaaS deploy. We need to give it the gateway. So the gateway is on my system, because I've got it all mapped nicely using console DNS. Gateway.service.console. And I want to specify the YAML, which is MachineBox.yaml. So let's do that. Okay, so that's come back with a 200 OK. Nomad status. We've got now OpenFaaS MachineBox that's running. It started at 2104, so just a couple of seconds ago. So now what I can do is I can test it. So if I cat Mitchell and Armand's picture, hashi.jpg, and I'm going to send that to the FaaS command, This time I'm going to use invoke. Again, I'm just specifying the gateway. And I want to give it the name of the function I want to invoke, which is going to be MachineBox. So the OpenFaaS gateway is basically just an HTTP endpoint. You can see over on the left there that I could actually do exactly the same thing that I'm using with FaaS invoke. I could just curl my JPEG payload to this API endpoint here. But FaaS CLI is super useful. So let's run that, and that's looking good because I got a whole load of junk back, which I'm guessing is binary of a JPEG. So if I then take the output of that and I send that to out. I think I said I was creating PNGs, didn't I? Yes, PNGs. Out.png. That's running there. Whoops. And if I open out.png, you can see that we've now got our image, and it's nicely highlighted, showing the faces. Again, in the FaaS CLI portal, I can see that I've got my new MachineBox image running. This is pretty cool because it's really nice for kind of rapidly testing stuff. And that's it. That is our function. And what I'll do is I've uploaded this to GitHub. And tomorrow what I'm going to do is I'm going to try and show you how you can take a TDD-based approach to your functions. Because I think if you're writing serverless, it doesn't matter like what you're doing in terms of your application, but it's always good to have tests. And I'm a big fan of TDD. I like TDD because it allows me to kind of think and validate as I'm writing the code. And the great thing about Golang is everything is very, very easy to test. So we're going to take an approach. We're going to make all of this code testable. Somehow it's going to be fine. And we'll do that tomorrow. So for now, thanks for watching. And if you want to check out some further information, MachineBox.io, definitely check that out. Some really cool stuff going on there. OpenFaaS, that's openfaas.com. Great project, great community. Check that out there. If you want to check out running OpenFaaS on Nomad's, HashiCore's Nomad, then there is a OpenFaaS playground, which you will find at katacoda.com/hashicore/scenarios/nomad OpenFaaS. And what we've got here for you is a full Nomad environment, which has got OpenFaaS and everything already up and running, so you can have a play around with that straight away. And that's all. Thanks so much for watching.